John. I'm going to talk about Tick, which is a time library. Not really going to explain what it is now, but you'll find out. I'm going to tell a story about when I started using Clojure 8 years ago. I was a sort of technical manager in a bank, and one of my jobs was to have to edit a cron tab file. I don't know if any of you have seen cron, but this is a syntax that you have for a scheduler on Unix. Which has kind of certain properties. The first number indicates the day that you're going to, the minute that you're running the job. So this is 6 o'clock in the evening on every single day. And the 1 to 5 means the days starting from Sunday. So Monday to Friday, I want to calculate my prices in London and their swaps. And the 0, I'm going to tell you what that means in a minute. We had a similar kind of setup in New York. So I could run at 6 o'clock, because that was after all of the trading had finished, run calculated prices in New York. Sometimes we had jobs that needed to wait until the New York jobs had finished because they were running in London, but because New York is so far behind London, we had to run them kind of at night. So this was 11 o'clock, which was 5 hours or 5.5 hours after, or half an hour after the New York jobs had run, because this is running in London, but on the New York swaps. And then when daylight savings time kicked in, it was fine because London and New York had the same daylight savings time, at least in the autumn, except for when the Energy Policy Act of 2005 came out, where George Bush signed an order to change the daylight savings time in New York so that it was for a week or so, 4 hours behind and not 5. So what happened is that we had to go in and change all of the cron tabs, and there were thousands of these. And it was my job to work out and to do all the change management forms and to sit on the calls and explain the risk of making these changes. So here I've moved back an hour, jobs that were running on London, they were running at 11:30 in the evening, now they're running at midnight, and they need to be now running on a Tuesday to Saturday, and this -1 was a value to tell the job to take away 1 from the day that it was running to work out which day to price. You following this? We also had, because the Energy Act was in 2005, many of our machines hadn't been patched, or at least had different versions of the database. So some of the machines in New York didn't actually know about this change in the law and were still running old versions, and so they didn't know what time it was. So we had spreadsheets saying which version of JVMs we had on what host, but also which patch level they had of the time database. And what I kind of then we had this other note. Then Sao Paulo came online. Now, in daylight savings time in Sao Paulo, it's slightly different because they're in the southern hemisphere. So instead of going back, they go forward. Does that make sense? No. Well, anyway. And so when I had finally got all of these cron tab entries changed, I sort of went home for the weekend, and my testing strategy was, I just really hope I didn't screw up on any of the calculations. So it wasn't a really kind of a fun job. Had to do it about 4 or 5 times, or 4 times or 8 times every year. Had to have this horrible kind of 1 week of paperwork. But I wasn't the only one that had this problem, and I know some amazing engineers in Apple have also had some issues with time. And time is a very, very hard thing to get right. We had James was on my team, James Henderson, and he and I came up with this idea for a better cron, which was rather than just hit and hope that these events go off in the right time, if we could at least see the events that were going to happen as a sequence, we could at least go home thinking, right, those are the time calculations. That's when things were being triggered. So what James and I kind of figured out how to do in Clojure sequences is how to disentangle this problem of knowing when something was going to run from when it actually ran. So Chime was something that James extracted, and it's an open source library on GitHub. My takeaways were that Not only is time is really a hard problem and a source of so many bugs. It's partly because the tools that we use are not very good and not up to the problem, cron certainly. The other thing I've noticed throughout my career is that using slightly the wrong tool or just making a small error can compound and compound until years and years later you're spending huge amounts of money. You have vast amounts of complexity and paperwork because you've made that small, you've chosen the wrong tool or the wrong library, or that library just hasn't been good enough. And I think this is where, as a community, Clojure programmers have a lot to give, because we have tools that are just slightly better than, in my belief, Clojure immutability and the improvements Clojure has as a language can be used early on to avoid quite a lot of complexity. So a quick brief history of time on the JVM. Our friend started Java util date. I want you to think about what date this is. You might have seen me do this before. We'll do it on the REPL in a minute. Java util calendar, pretty hard to use and unintuitive. Months begin with 0. So we had big improvement a few years ago. Joda time came out, which was a comprehensive library, easy to use, and it became a JCP called 310, which is really clean up and make time much easier on the JVM. That became Java 8 Java time. In the Clojure world, CLJ time was a wrapper around Joda time, but it's a wrapper around the old Java classes. So the new Java 8 has been wrapped by Vadim Platinov, Clojure Java time. So Tick is a little bit like that last one, in that I started wrapping Java time, Java 8 time, and I wasn't aware that this library existed. So they are quite similar, and I think this is a very nice and mature library. I know some people are already using it, and it's about 2 years old, and I think it's quite stable and mature. I'm gradually learning from this language and kind of, if I'm honest, stealing some bits out of it into Tick. So I just want to give a quick rundown on Tick, and I'm going to do a live demo in a minute. So Tick is a wrapper around Java 8 time. It has chime-like sequences for scheduling, and I'm going to show what those are. But it's very experimental and fun. I'm still kind of playing around with it and trying to get it consistent, ready for a release. But it's a good time to talk about it because I quite like any feedback that you have to, if you've got any ideas or any places that I could take it. I was in conversation over the summer. Wendy got me introduced me to Eric Evans, who was here for a conference, and we got chatting. And Eric was building a time library in Clojure, and he discovered this paper by Alan, I think about 1982, called Alan's interval algebra. So I'll be explaining a little bit of that, and I've done an implementation in Tick. So Alan's interval algebra is about how time intervals can relate. And Alan proposed 13 different ways in which intervals can relate, which we're going to be seeing in a minute. Okay, quick demo. I know that the software demo fairies are out in force today. So hopefully this will work. So this is Tick. What can you do with Tick? You can ask what the time is now. This is giving us a Java time instant. I can ask what day it is today, or at least what is the local date. That's correct. I can say you're a Tuesday. Okay, that's good. I can create a duration of 8 hours. All of these types are types that you can get in Java 8. I can do some arithmetic. Let's add to duration. That's 8 hours plus 2 hours, 10 hours. I can add some time to now. Okay, so let's try and model the problem that we had with the crons. We want to have, we want to start with today, and we want to calculate a set of days, but we're going to avoid weekends. So I'm going to simply use iterate. So let's take 10. So we will start with adding. Take 10. So here we are getting a sequence of days, 5, 6, 7, 8. But we want to filter out the weekends. So we'll say filter, and I have a function in tick called weekends. Oops. I think that's the first fairy coming at me. No. Oh, deprecated cow. There we are. So there's a whole lot of calendar stuff in tick that for calculating things like bank holidays and things, which I've decided to kind of deprecate but keep in the API. I'll get to why that is later. So now we want to, now having got these days, let's put a for loop for day in that. Oops. Let's go to so for day, we're going to return a day, but we also now want to create a time. So just do some copy and pasting. So here, what I've done here is saying take the day, and then take that day and let's have 8 o'clock at that day. So at today. And that's going to give us a local date time. So we're turning a date into a time. And we're saying that's a local time. I want to put it into a zone date time. So I'm saying that's at the zone, New York. So these are the kind of things that the operators that cron just simply doesn't have, and it allows you to kind of work in a quite flexible, dynamic way with time. I've chosen to design the API to be very suited to experimental, taking data and mucking around. So I've tried to keep it as sort of short as possible, which is why I've used list symbols. One of the symbols that I have, for example, is divide. So we've got plus and minus, multiply. So what does divide do? Well, we can take today and divide it up into 8 intervals. Or it can take a month. Let's take a month. I can say year month of the year month. I'm going to divide it up into days. So here are all of the dates in the month. So division is a very useful thing to have. Okay, so now I'm going to do some kind of visualizations, because when you're working with these intervals, it's kind of easier to see what you're doing. So I'm going to create some intervals here. So here's the interval to today. Every kind of thing, every concept in tick that can span any time range has a beginning, which is midnight, and an end, which is midnight tonight. So I'm going to create an interval. So that's today. I'm going to create an interval yesterday and tomorrow. Okay, so now in a kind of Brett Victor-like demo, I have 3 rectangles. The left is yesterday, middle is today, the right is tomorrow. Let's label them. So I have a label. You can see on the left-hand side, my font might be small. Label. Okay. Okay, it would be nice also to show the days of this month. So I'm going to take my year month. It's called a year month in Java 8 time, as opposed to a month. We can say what the month is, but the month is January, February, December, that sort of thing. So this is actually the month of December in 2010. We're going to divide it up into days. Okay, and then so now what we're seeing is a bunch of days for all of the December, and we can see, because it's the 4th today, no, it's the 5th today. Yesterday was the 4th, and that's why it's in the 4th position. It might be easier for me to label them, so I'm going to say 4 day, oops. Oh yeah. Cheat sheet. We're going to get magic. There we go. So now we've labeled all the days up until December. Okay, so that's the visualization. It's not built into tick, it's just kind of something I was playing around with to demo. But really what's happening on the visualization is that I'm taking an old Java library called Batik, which allows you to render SVG. And I'm generating the SVG hiccup style. So for here, I'm just taking sets of intervals, and then each row is a kind of set of intervals. So I've got December in the first row, and so on. It's not a lot of code to do this. And I quite like working, doing quite a lot of work this year in complicated document builds. And I do quite like being able to pull up some SVG and try and render what I'm trying to get into my head. And I found that to be quite a useful, interesting style to make use of some of kind of Java's rendering to make that easier for me to figure out what's going on, particularly when you're working with time, because as we know, time is hard. Something else that's quite hard is we want to now, just to finish up, demonstrate how I'm going to go into April, and April was a good month for me because I actually got some holiday. And I want to count up how much holiday I used in April so I could take it off my Juxt employee holiday allocation. Now, you might think that's an easy thing to do. I found it a very difficult thing to do. But hopefully with the visualization, you can see how I've gone about doing it. So I've called these vacations. So I'm going to put my vacations in here. There they are, all the way down over there. So we really kind of want to remove, you can see they're over there because they're in April. So I'm going to constrain the visualization to April. So there's April. Let's take these ones out. Okay. So this is the month of April. You can tell it's 30 days. And I took a day off on the 3rd, and then I went to the Isle of Wight. Okay, so how many holidays did I take off? Well, we need to put the weekends in here, really. So let's put weekends. There's that weekend again. Okay, I've been able to throw in the weekends by taking, again, the days. And I said, but only when the day is a weekend, then I want you to create another set of intervals. Okay. So, but that's not the whole story, because we also have April is where Easter was this year. So there's a function holidays in England and Wales. And this is giving us these holidays. So I'm going to map date over them. And that's given me a set of local dates. Map their intervals. So this interval stuff is quite interesting. You can, for example, we can say, is tomorrow less than today? What would we expect that to be? No, it's not. What about, is today less than tomorrow? Well, kind of what does that mean? Well, it does return truthy. What about the year month of today? Oops. Okay, that's a year month. That's not, I mean, what sense is this month less than today? I mean, it starts before today started, but it's longer than today and it ends after today. So it doesn't really make sense to use a less than operator for this. And really what we're really asking is, what is the relation between a month and tomorrow? And we ask for the Allen relation. It tells us that the month contains tomorrow. That is the relation. So what we've asked is, this is the month and this is tomorrow, so we're actually using this relation here. So it is quite useful to know whether two time intervals are disjoint, because so if I look at, there's a disjoint I think that's don't know where that one is. Okay, because by being able to tell whether two intervals overlap or not, if you're, for example, taking a holiday and you're filling in a timesheet for a client, you want to make sure that you're not actually billing time to a client when you're on holiday. So it's useful to have checks to make sure that the relations are not overlapping or containing each other. So the relation calculus can allow you to build and compose useful functions that you can apply against your interval sets. Okay, so let's go back to our, let's put in some So we've got our holidays for the year, and oh dear, by asking for the holidays for the whole year, we suddenly kind of ruined the visualization, because the holidays across 2017, now we're going from January, bank holiday, New Year's Day, all the way to Boxing Day, or whatever. So what we want to do is constrain those holidays and fit them into the frame of April. Okay, so I'm going to treat these holidays as a set. And sets, we have operators like union and intersection, which I've kind of copied to move into this kind of time paradigm. So what I'm going to do here is say, give me the intersection between the interval, which is this month, or April in this case, and the holidays. So the intersection is what holidays fit in April. And now we're back to the nice visualization. So we've got here, I haven't labeled them. This one is Good Friday, and that one's Easter Bank Holiday Monday. So that's good. So really we want to treat those as off days, weekends and bank holidays. So let's call those off days. We'll say we're going to union these things together. And now we've got all our off days, and we can see the holidays. So how many holidays did I take off? I've got 2 here, 18 and 19, and the day off here. And I can do that by, I'll put that in a let. I'll call that off days. And now I've got the vacations. I can now say, what is the difference, or between my holidays? Let's take off the off days. So what I've done there is I've done the calculation of what days I'm off, and I've got 3. Now I could count it at this stage. So rather than view it, let's take that, see what those off days are. I've got 2 intervals here. One's between the 3rd and 4th, the other's between 18 and 20. So it should just be a matter of adding them up. Sorry? That's the parentheses. I've got map duration. Okay. There we are, 72 hours. Divide by 24. 300, yeah. Yeah, okay. We've got 3 days. That's how much time I took off. But the point of this isn't to show you that I can count. The point is to separate the computation from working out which days to count and then counting them. In most counting systems, you would ask, count me my holiday days, and it would go on and say, well, is this a weekend? Is this a bank holiday? Keep incrementing. You'd see that really ugly for loop. And we would be putting together the calculation of holidays and weekends with the counting itself. What we've done now is separate the computation so that we now see what days we're off, and that we might want to count, we might want to do something else. We might want to generate an iCal feed, or we might want to put out into a database or let people know, or we might want to do any actions. So the important thing here is that we've created a kind of set of functional primitives to operate on time, which allow us to do fairly complex things and be sure of the result without hopefully getting into bugs. So just as the kind of the remaining thing to show you using this intersection is what happens if I booked holiday between Christmas and spreading over into New Year, when I've really got this problem of spanning that. So what does it intersection do at that point? So I've got this. So let's have a holiday between the 4th of December, actually that's a bit generous, and it's not going to happen. So let's just do that, and the 8th of January. Well, that's okay. And then we're going to do, so that's the holiday that I want to take between 27 and 2018. Okay, so what we can do there is we want to know what bit of that holiday is in 2017. Well, we just use the intersection. That'll appear there. If we want to know which bit is in 2018, it'll appear here. So the intersection operation will actually splice your time to fit in. Okay, and I'm out of time. So just to wrap up quickly, future work, lots of things to steal out of Vadim's library, mostly around the ability to take times and truncate them to the nearest hour and nearest day. There's some very, very useful things in that library, and I'm kind of pretty close, as 80%. So I don't really know whether to depend on that library. Some of the terminology I've used is quite different. It would be great to have this kind of functionality in ClojureScript. I did want to do that and show you kind of a ClojureScript demo. I think most of the JavaScript date libraries are pretty poor. They allow you to convert between text and dates, but there's not a lot of, or maybe adding up and some basic arithmetic. But I think having this kind of powerful time functions would be very useful in ClojureScript. And there's more work to be done in making the API, super unsurprising and consistent. Anyway, I hope that has helped whet your appetite. I'm not really trying to promote tick here, but I'm trying to promote the ideas that there's lots and lots of very thorny, difficult domains out there that we as a Clojure community can help to simplify and bring to our colleagues and really help to improve the quality of what we do and improve the simplicity of what we do in our work. So thank you very much.